Okay, it's that time again where we have a look at the solutions. Okay, so the first bit was nice and easy. Turn it into an improper fraction. So this becomes 12, sorry, hold on, 12 over 7 multiplied by 35 over 16. Then use your calculator to multiply them and you get, well, actually you can cancel out. Let's do that. So 7 goes into 35 5 times, and then 4 goes into both 12 and 16. Goes into 12 3 times, 4 goes into 16 4 times. So then what you're left with is 3 times 5, which is 15. And 1 times 4, which is 4. And when you turn that back into an improper fraction, it's 3 3/4. So that's how we had it before. Sorry, not an improper fraction, a mixed number. Okay. Next was nice and easy. You just had to say what the upper and lower bounds were. If it's to 1 decimal place, that means it's to the nearest 0.1. You halve it, and that means that the upper and lower bounds are plus or minus 0.05. Add 0.05 for the upper bound, so that's 1.45, and subtract 0.05 for the lower bound, so that's 1.35. Next here, nice and easy, multiply the indices because they're in brackets there. So 3 times 5 is 15, so p to the power of 15. Here we need to multiply, and most of you got this right to be fair, multiply out the brackets 2n times 4n plus 3 and n times n take away 4. So 2n times 4n is 8n squared. 2n times 3 is 6n. And then n times n is n squared. N times minus 4 is minus 4n. So then we need to simplify this so we can put together 8n squared and 1n squared, which gives me 9n squared, and I can also then do 6n take away 4n, which gives me positive 2n, and that's it. Yeah, so that's that one. Okay, next, to solve this, so the first thing we want to get rid of is the denominator here. So we want to get rid of this denominator here. So I'm going to multiply both sides by 3. So multiplying this side by 3 just gets rid of it. So I get 2x plus 5 on that side equals, I've got to multiply all of this by 3. So I get 12 take away 3x, because 4 times 3 is 12, and minus x times 3 is minus 3x. Then I can solve it in the normal way. I'm going to add 3x to both sides to get rid of the minus 3x here. And so I get 5x plus 5 equals 12. And then I subtract 5 from both sides to get rid of the plus 5 there, and that gives me 5x equals 7, and then I divide both sides by 5 to give me x equals 7 over 5, or if you wrote it as 1.4, that is also fine as well. And they did allow you to have that. Okay, the Venn diagram. List the members of the set B. So that is everything within this set here, everything within set B, and so that would be 2, 3, 5, 7. You don't have to write it in numerical order. I just prefer that way, but the other way is absolutely fine. Then it says A and B. So A and B, you are just looking at the intersection here. So that's just 3 and 7. Next bit, you need to be a bit careful. So list the members of not A. So if you know that all of A is here, so I'll use a different colour. This is all of A. So you can't put any of those in. Everything else will be not A. So it's all the numbers that are left. This one, this one, this one, this one, and this one. So our answer is 2, 4, 5, 6, and then 8. Okay, so it's all the numbers that don't belong to set A. Right, nice straightforward trigonometry here. So we label the sides, we've got the hypotenuse, and we've got the adjacent. So hopefully you'll figure out quite quickly that we needed to use ka out of SOHCAHTOA. And if you cover up what you're trying to find, so we are trying to find the adjacent, to cover it up, it's telling us to multiply. Okay, so our answer should be 8.6 times cos 43. And then when we use our calculator to work that out, it gives us 6.3. Okay. Right, some good old probability. Right, we know that all these probabilities here should add up to 1. So let's see what it adds up to so far. We need to add up 0.14 plus 0.17 plus 0.21, and that comes to 0.52. Subtract it from 1, because we know it needs to add up to 1. We get 0.48. That means these two that are left must add up to 0.48. And since it tells us that the probability the spinner will land on 1 is the same as the probability that the spinner will land on 4, we can just split it in 2. So we can just do 0.48 divided by 2, and they both have a probability of 0.24. So then now to find out how many times it will land on 4, if we spin it 400 times, we're going to do 400 multiplied by 0.24, and that gives us 96. Yeah, so it's going to land on 4 96 times. Here, this was quite a nice question. You just had to draw these lines. So you had to remember that x equals 3 means that it's a vertical line. Just going to make it slightly thicker. It's a vertical line going through 3 on the x-axis. Same for y equals 1. It's a horizontal line going through 1 on the y-axis. Yeah, so you just have to try and remember x is always vertical and it goes through that number on the x-axis, and y is always horizontal and it goes through that number on the y-axis. X plus y equals 7, maybe a little bit harder, but have a look. So whatever x and y are, they add to make 7. So you could have 0, 7, because 0 plus 7 gives you 7. 1, 6, because 1 plus 6 gives you 7. 2, 5, because 2 plus 5 gives you 7, and so on. 3, 4, 4, 3, 5, 2, 6, 1, 7, 0. And so this is your line. That's your line, x plus y equals 7. And that's all they wanted you to do for that particular one. Okay, here, this one was quite nice. So you're looking for a number that multiplies to make minus 24, but adds to make positive 5. So it's x plus 8, x minus 3. Okay, and that's all you have to do for that. Here, then you can solve it. So if you know that x plus 8 times x minus 3 equals 0, then your solutions are x equals minus 8 or x equals positive 3. Okay, remember where it says hence, it usually means that the first part will help you with doing this. I know some of you try to use the quadratic formula, but you were wasting your time, especially for 1 mark. They just wanted you to use what you did in part 1 to then do part 2. Okay, so now we're solving. Okay, what I would first of all do is make this one single fraction. And in order to make it one single fraction, I need to make both denominators the same. So I'm going to make both denominators 15. To do that, I'm going to multiply this first one top and bottom by 3. And then I'm going to multiply this one top and bottom by 5. So then I get 9x plus 6 over 15. Take away 10x plus 5 over 15. And that equals x. Okay. Doesn't matter which one I do first. I can combine them and then get rid of the denominator. So I'll combine them. I've got to be careful with my signs because remember it's take away all of this. So 9x take away 10x is minus x, minus 1x. And then 6 take away 5 is positive 1 over 15 equals x. And then to get rid of the denominator, I'm going to multiply by 15 on both sides. So that gets rid of the divide by 15. And then what that leaves me here is minus x plus 1 equals 15x. Then add x to both sides to get rid of the minus x here. I get 1 equals 16x. And then to get x on its own, I need to divide both sides by 16 to get rid of the times by 16 here. And that gives me x equals 1 over 16, and I can just leave it like that. It's better to just leave it as a fraction. Right, number 10. So this gives you some information. It tells you that this table is for year 11 and that the pie chart is for looking at year 10. Now, I'm going to use this information because I know how many students there are in total in year 11. It tells me there are 320 students in year 11. So the first thing I'm going to do is do 3x plus 6 plus 5x plus 8 plus 7x minus 9, and that must equal 320. So all I did was add all of these up. I'm going to simplify, and that gives me 15x plus 5 equals 320. So then I subtract 5 from both sides. And that gives me 15x equals 315. Divide both sides by 15. And I get x equals 21. Okay, so if I got x equals 21, I can now find out how many said that biology was their favourite in year 10. So I can do that for year 10. So in year 10, let's work that out. So year 10, oops. Year 10, it says 3x plus 6, like biology. So 3 times 21 plus 6, that means 69 like biology, or said that biology was their favourite. Let's now do it for year 10. So year 10, when we look at biology, we've got 126. So year 126 degrees. So 126 degrees out of 360. So that's the fraction of 300 that like biology. Okay, so instead of a whole circle, I've got to do 126 out of 360 and then times that by 300. And that gives me 105 like biology in year 11. But it's asking us how many more. So I need to find the difference. I need to do 105 take away 69, which gives me 36. So 36 more preferred. So 36 more students in year 10 said that their biology, in year 11, said that biology was their favourite science subject. Okay, now for this one. So we need to find the perimeter of the shape. Now to find the perimeter of the shape, we're missing 2 lengths. We're missing this length here and we're missing this length here. Okay, so the first thing I can do is, using the information they've given me for the area of the trapezium, I can find AB. Okay, so I know to find the area of a trapezium, I would normally do half of top plus bottom, so AB plus 14, and then I would multiply by the height, and in this case the height is 15. That gives us 360. So then I can undo all of this and work backwards. I can divide by a half, and that gives me AB times 14 times not AB times 14, AB plus 14 times 15 gives me 720. Then I can get rid of the times by 15 by dividing by 15. So I'm going to divide by 15. So I'll just write what I did at the very beginning. I divided by a half. And so that gives me AB plus 14 equals 48. And then I subtract 14 from both sides to give me that AB is 34. So I now know that this length here, all along here, is 34 centimetres. But I now need to find the diagonal, so I'm going to make it into a triangle. And I can use Pythagoras because this is a right angled triangle, upside down, but it's still a right angled triangle. This is 15. Along here, I know that the whole way across is 34, but up until this point is 14. So here must be 20, just this bit here must be 20. So I'm going to use Pythagoras, it's the longest side, so I'm going to do 15 squared plus 20 squared, which gives me 625. Then square root 625 gives me 25. So I know now that my diagonal is 25 centimetres. I can now add all of that up. So I've got 14 plus 15 plus 34 plus 25. And this is for the perimeter. So remember, all I'm doing is adding the 14, the 14 plus the 15 plus the 34 all the way here plus the 25. And that adds up to 88 centimetres. Okay, here we want to find the length DC. So we just want to find this bit here, DC. So the first thing we're going to do is treat the whole thing as one big right angle triangle. So I'm just going to highlight the bit that I'm looking at. So I'm looking at this as my triangle, first of all. So I've got a right angle. I do know what this whole angle is, so I can treat it as a whole triangle. The way to find that out is if I treat it as one big triangle, I know that's 90, that's 24, so I do 90 plus 24, which is 114, and then 180, take away 114, gives me 66. So this here, this whole thing here is 66 degrees. So I'm now going to find out what this is, BC. So I'm going to find out the whole of BC. So BC equals, if I look at 66 degrees, that is the opposite. This is your adjacent because it's next to the 66 degrees. So you should know that we're going to use TOA. When you cover what you want to find, which is the opposite, it is telling you to multiply. So it's saying to you that we have to do 4,250 multiplied by tan 66. And that gives me 9,545.6. And that's the whole of BC. Then the other thing that I can work out is BD. So I can work out what it is just up until that point. And for that, I'm going to take this smaller triangle here. Okay? So then BD is essentially the same thing. BD, I'm now only using this angle here, the 47. So that's still the opposite. And the 4,250 is still the adjacent. So we're using tan again, and we're going to multiply. So we're going to do 4,250 multiplied by tan 47. That gives us 4,557.6. And then it's a simple case of, to find DC, I'm going to subtract the whole length. So the whole length, remember, is 9,545.6. And from that, I'm going to subtract this little bit that I found here, and that will leave just DC. So I'm going to subtract 4,557.6. And that leaves me with 4,988 metres for DC. Okay, moving on. Okay, most of you got this right, which was really good. So hopefully you read it correctly. So on Saturday, if the probability that he gets to work early is 0.7, then the probability he does not is 0.3 because they have to add up to 1. Now you have to read it properly. It says that if Thomas gets to work early on Saturday, the probability he'll get to work early on Sunday is 0.9. And again, because we want it to add up to 1, the probability he does not get to work early on Sunday is 0.1. But instead of repeating that, the next sentence goes on to say, if Thomas does not get to work early on Saturday, the probability that he will get to work early on Sunday is 0.6. Again, because I want it to add up to 1, this will be 0.4. Okay, so that gets you 2 marks. And then it asks you for what is the probability that Thomas gets to work early on both Saturday and Sunday. So early, we multiply along the branches. So we multiply 0.7 times 0.9, which gives us 0.63. And so that's our answer. Number 14 is quite a hard one. So it's asking you to find the size of angle BMP. So let's draw it in. So I can do it better than that. Sorry. BMP. And we'll just join that up as well. Okay, so we're trying to find that angle there. Now, it might not be immediately obvious, but we're going to need to do advanced trig. And we're going to have to use the cosine rule specifically because there's no other angle involved. We only have one angle that we're trying to find. So what we can do is we can find 3 sides and use the cosine rule. Because the other thing is that this particular triangle is not a right angle triangle. So we have to use the cosine rule. So for that, we need all 3 sides. So we need to find the different, lengths. So I'm going to start off with one of the easy ones, which is MP. So we can make a right angle down here. Oops. A right angle down here to the edge. That's 8. And then halfway across the rectangle. Remember, the whole way across the rectangle is 12 centimeters. So halfway is just going to be 6. And MP is the hypotenuse. So MP equals the square root of 8 squared plus 6 squared, which is the square root of 100, which is 10. So we know that this is 10. That's fine. We've done that one. The next easiest one to find is BP. Because here we have a right angled triangle with the corner. So that's a right angled triangle. And we can use that to find BP. We know that this whole side here is 12. And then halfway along this edge, instead of the whole way, which is 20, halfway must be 10. Okay, so that bit is 10 as well. And we're finding the hypotenuse again. So we're going to do 12 squared plus 10 squared and square root it. So that's the square root of 244, which is 15.6. Then the last length that we're going to find is BM. So BM is this side here that we want to find. Now to form a right angle triangle, we are going to use this and then here. Okay, so that's our right angle triangle. So we know that this is 8. What we don't know is this length here. But we can figure out, I'll use a highlighter so you can see where I'm pointing to, but we can use Pythagoras, to find all of that along there using this right angle triangle here. Okay, so we're going to find AE. I think I'll do it in the corner here. So AE, so all the way across, is the square root of 20 squared plus 12 squared, which is the square root of 544, which is 23.3 roughly. But I only want half of that. I'm only going up to AM. So half of 23.3 is 11.7. So I now know this is 11.7. So to find BM, I need to find the square root of 8 squared plus 11.7 squared. Obviously, when I'm doing it on my calculator, the 11.7 that I found by halving the square root of 544, I actually used that as my previous answer in this calculation so that I get an accurate answer. So that's the square root of 200, which is 14.1. So now that I have all three sides, I can now use the cosine rule. Now, two things to bear in mind. You can either memorize the cosine rule and rearrange to find the angle, which is cos A equals B squared plus C squared minus A squared over 2BC. Or the other thing is if you cannot memorize this, it's to go back to your formulae sheet at the very beginning here. And here's your cosine rule, and it's to rearrange this. So remember, the cosine rule they give you in the formula sheet is to find a missing side. To find a missing angle, you will need to rearrange this. Or, as I mentioned earlier, you need to need to memorize the rearranged form. Okay, so let's go. So it doesn't matter which is B and which is C. What does matter is which one is A. So A is always the one that is opposite the angle that you're trying to find. So BP in this case is A, and the other two, it doesn't matter. Okay, so cos A equals 10 squared plus 40. What I might do is use my original square root of 200 squared, only because, so again, just so that I don't have to put too many previous answers in my memory, the memory of my calculator, I can just use it like this. Take away A squared, which is the square root of 244 squared, divided by 2 times 10 times the square root of 200. Perfect. That gives you cos A, once you've done that on your calculator, 0.19798, so and so on. Then we do the inverse cos to find the actual angle. So we did inverse cos of 0.19798. and that gives me an angle of 78.6 degrees. Okay. Right. This one, it doesn't matter which order you multiply in. I'm going to multiply these two first. So I'm going to do 3x multiplied by 2x, take away 1. 3x times 2x is 6x squared. And 3x times minus 1 is minus 3x. Now I take this answer and I'm going to multiply it by the last bracket. So I'm going to take 6x squared minus 3x and multiply it by 5x plus 4. So then I fill it in. 6x squared times 5x is 30x cubed. Minus 3x times 5x is minus 15x squared. 6x squared times 4 is 24x squared. And last of all, minus 3x times 4 is minus 12x. We can gather any like terms, and so we've got 24x squared and minus 15. Oh, you can't see that. I'll do a lighter colour. 24x squared, take away 15x squared, and so what you're left with for your final answer is 30x cubed. 24 take away 15 is 9, so 9x squared minus 12x, and that's what you've got as your final answer. Okay, here we want to work out what the area of the sector is. In order to work out the area of the sector, I need to know what the radius is. And so I'm going to use the information they've given me for the area of the triangle. So I know that I'm going to use my advanced trig, so I'm going to use half AB sine C. So I know that the area is half times the radius squared. So this is because they're both radii here and here. So that's what A and B are. So radius squared times sine 50 in this case. And we know that equals 120. You can do it all in one go, but I'll just do it in steps so you can see what I'm doing. So I'm going to divide both sides by a half, and I get r squared sine 50 equals 240. Then I'm going to divide both sides by sine 50, and I get that r squared equals 313.3, and to one decimal place I square root it, so I'm going to square root that, and I'm going to get that r equals 17.7. And again, I can leave it as my previous answer, so I can use it in a moment. So r equals 17.7. Then you know that to find the area of a sector, we need to find the area of a whole circle, which is pi times radius squared. So 17.7 squared. And then we need to find a fraction of it. And in this case, it's 50 out of 360, because I do not want the whole circle. And that gives me 137 centimetres squared. Okay, express this in the form n square root 27. Gives you a massive clue. It shows you that 27 must go into 675. So you can use your calculator and do 675 divided by 27, and it will show you that square root of 25 times the square root of 27 gives you the square root of 675. Let's tidy it up. We know the square root of 25 is 5. So 5 square root 27 in that set. Okay, part B, I've shown you questions like this before. Whenever they say, sure, it can be written in this form, and you can see that we do not have a surd in the denominator anymore, it wants you to rationalise the denominator. So when you're looking at what topic this is rationalising the denominator. We don't want a surd in the bottom anymore, in the bottom half. So if you remember your lessons on this, we are going to multiply top and bottom by the same denominator but change the sign. So we're going to multiply top and bottom by square root of 2 plus 1. Okay, and you have to do it on both top and bottom. So let's sort out the numerator first by working out what 5 minus the square root of 2 times square root of 2 plus 1 is. So 5 times the square root of 2 is 5 square root 2. Minus square root of 2 times square root of 2 is just 2. 5 times 1 is 5. And the square root of 2 times 1 is minus square root of 2. Okay, and then we gather like terms. We know that 5 plus, so that should be minus 2. So square root of 2, minus the square root of 2 times square root of 2 is minus 2. 5 take away 2 gives you 3. And then here we've got 5 square root 2, take away 1 square root 2. That leaves you with just 4 square root 2. We're going to check the denominator and do the same. We're going to multiply out the denominator, but you should find that it disappears. Let's have a look. Square root 2, take away 1, multiplied by square root of 2 plus 1. Square root of 2 times square root of 2 is 2. Minus 1 times square root of 2 is minus square root of 2. Square root of 2 times 1 is just the square root of 2. And minus 1 times 1 is minus 1. And again, gathering like terms, 2 take away 1 is just 1. And square root of 2 take away the square root of 2 cancel each other out. So the surd has disappeared. And over 1 is just the same as saying 3 plus 4 square root 2, which is exactly how they wanted it. Okay, so histogram. The first thing I'm going to do is work out how many people there are in total that completed this puzzle. Now remember, this is not a bar chart, so I cannot read the frequencies off the y-axis. The frequency comes from the area of the graph. So I'm going to find the area of the graph. So for example, this bar here is 10 wide and up it's 1.5. So I'm going to do 10 times 1.5, which gives me 15. So 15 people took, or students in this case, took 0 to 10 minutes to complete this puzzle. Then here, 10 to 25, that's 15 wide, so 15 times, it is 0.8, so 15 times 0.8, which gives us, did I work this one out, 15 times 0.8, which gives us 12 people, or 12 students here. This is 25 to 30, so it's 5 wide, so 5 times 4, so 20 people, 20 students here. Here we've got 30 to 60, so 30 times, and the height there is 2.5. Which gives us 75 students there. And the last one is 5 wide and 4.6 high. So 5 times 4.6, which gives us 23. And so if we add all that together, I've got that there are 145 in total. Now, I want to find the fraction of people who only took, if I use a different colour here, only took 20 minutes. So here is my cutoff, 20 minutes to 60 minutes. So I want this, all of this, and all of this. Okay, so this bit I already know. So these two bars here and here, I already know. So I've got 20 plus 75, and I just need to find this little bit here. So from 20 to 25 is 5, and then it's times 0.8. So 5 times 0.8 is 4. So that gives me 99 in total. So 99 out of 145 completed the puzzle in 20 to 60 minutes. Here we've got some index laws, which actually, out of all the ones they could ask, this one was quite a nice one. So if we take this side first, when we're dividing, remember we subtract the indices. So we're going to do 2n plus 3, take away 4. So 2n plus 3, take away 4. And that leaves you with 2n, take away 1. So that's nice and easy. Let's look on the other side then. We are multiplying. So when we are multiplying, we add the indices. So we're going to do 3 plus 1, take away 2n. So 3 plus 1, take away 2n. And so we end up with 4 minus 2n. And we know that they're equal to one another. And so let's solve it. I am going to add 2n to both sides to get rid of the minus 2n here. And I end up with 4n, take away 1 equals 4. Then I'm going to add 1 to both sides to get rid of the minus 1 here. And that gives me 4n equals 5. And then I will divide both sides by 4 to give me n equals 5 over 4. Okay, if you turned it into a decimal, that is also fine as well, which I think is 1.25. Okay, so next one, you have to use algebra for this. You cannot get full marks if you don't use algebra. So we're going to say that x equals our recurring decimal, so 0.7636363. So note that the 7 stays the same, it's just a 63 that recurs. Okay, so I want to get rid of the recurring bit here. So I'm going to first find out 10x. So if I times it by 10, I get 7.636363 and so on. Then I need another one where the 63 only occurs after the decimal point. So I'm actually going to multiply by 1,000. So I'm going to find 1,000x. If If I times it by 1,000, I get 763.636363, and so on. I subtract the two quantities and I get 990x is the same as 756. I divide by 990 to get that x is 756 over 990. So it's saying that's what the recurring decimal is, but we can simplify it. And so the biggest number that goes into both top and bottom is 18. So divide it by 18. And I end up with my fraction being 42 over 55, which is what I wanted in the first place. So that one is fine. Okay, for this one, I think you got 1 mark for saying the upper and lower bounds here. And I always think it's worth it anyway and I like to as well, just to organise my thoughts. So I always do myself a little chart like this and find the upper and lower bounds for all my values. So I've got x equals 28.4 and it's to 1 decimal place, so to the nearest 0.1, half it, which means that my upper and lower bounds are plus or minus 0.05. So my upper bound is 28.45 and my lower bound is 28.35. Next one, y is 17. Now you've got to be careful with significant figures. Significant figures, in this case, it's to the nearest whole number. So half of 1 is 0.5. So my upper and lower bounds are going to be plus or minus 0.5. So my upper bound is 17.5. My lower bound is 16.5. Now for the last one, w equals 90. It's to the nearest 5. Half of 5 is 2.5. So my upper and lower bounds are going to be plus or minus 2.5. So my upper bound is 92.5 and my lower bound is 87.5. So I've done almost the hard work and now I need to plug it back into here. So t equals x squared plus y squared. So I'm trying to find the upper bound. So I can use the upper bound of x and y. So I'm going to do 28.45 squared plus 17.5 squared divided by w. Now, because I'm trying to find the upper bound for t overall, in order to, when I divide it, I want it to still be the biggest number I can get. I need to divide by the smallest number. So I'm going to divide by the lower bound of w, which is 87.5. And so I put that in my calculator and I get 12.8 for my upper bound of t. Right, number 22, out of all the perpendicular questions they could ask us, this one was quite nice, to be honest. So we know that L is perpendicular to this equation here. So let's find the gradient of this line. I rearrange it so that it becomes y equals 9 minus 2x. So all I did was take the 2x over to the other side. I can then pick out the gradient straight away. It's minus 2. And remember, when two lines are perpendicular, the gradients multiply to make minus 1. So minus 2 times the gradient, I'll call it m1, equals -1. So those two should multiply to make -1. And so you can either do it on a calculator, or some of you remember that to find the perpendicular gradient, you just flip this and change the sign. Either way, it doesn't matter. You should realise that now the gradient is +1/2. So now we know that our equation looks like this. Y equals 1/2 x plus something. I need to find where it crosses the y-intercept by plugging in the only point they've given us. So I'm going to substitute x for 8 and y for 11. So 11 equals 1/2 times 8 plus c. So 11 equals 1/2 times 8 is 4 plus c. I take away 4 on both sides, and that gives me that c equals 7. So then my final answer is y equals 1/2 x plus 7. So that one's done. Okay, so this one was also another interesting one. So here we know that A or not A or B gives you 26. So if you first of all work out what A or B is, so let's do that. I might use the bigger, yeah. A or B is all of this. All of this. So A or B is that. That means I want whatever is left over because I want not A or B. So I know that these two here, 5x plus 3x plus 2 equals 26. So then I tidy it up. 8x plus 2 equals 26. And then I take away 2 from both sides and I get 8x equals 24. Divide both sides by 8 and I get x equals 3. So I'm almost there. So I now know what x is. It's asking me now for, let me take this bit off so you can see clearly. It's asking me now for not A and B and C. And so not A and C. So we don't want A, anything belonging to A and C. So in fact, I'm going to highlight that. So I don't want any of that. I don't want anything that also sorry, not A and C. So I don't want that. I don't want this bit here. Because, and I don't want the outside. Okay, so what's left is this bit, that's C only. So that's just C, not, sorry, it's also partially B and C, but no, there's not any A there. So here we've got 5x plus 2x, which is 7x. And we know what x is, so we can do just 7 times 3, which equals 21. So we've worked that one out. Right, the next one was also a bit of a long one. You had to factorise to tidy this up, I'm afraid. There was lots of factorising to do here. Right, first of all, I'm going to factorise a little bit by taking 4 out. So 4 goes into 16 4 times, so 4x squared, and 4 goes into minus 36 9 times. So just factorise that. Divided by, and the easiest one to factorise is the bottom. You're looking for two numbers that multiply to make minus 14, but add to make minus 5, and that is x minus 7 and x plus 2. And then we need to factorise the top. I've taught you how to do this before. Everyone has their own method. I tend to go the long way because it guarantees you getting it right. So you do 2 times 6, which is 12. So we're looking for two numbers that add to, multiply to make 12, but add to make 7, which is 4 and 3. So 2x squared plus 4x plus 3x plus 6. So I'm just rewriting this, but splitting the 7x into the two numbers I found. Squiggly line. I factorise this side, so 2x, and then 2x again, 2x plus 2, plus 3. And that should be, so I've gone wrong somewhere there. Hold on. Sorry, that should have been x plus 2. Plus 3, take 3 outside the brackets, and I get x plus 2. Okay, so now my factorisation, I take the 2x and the plus 3, so 2x plus 3, and in the repeated bracket x plus 2. I've now factorised that and take away 7 plus 8x. Okay, not long to go. Right, then I should realise that this one here is, sorry, let me just do it so you can see it, is a difference of 2 squares. So I have 2 square numbers, 4 and 9, and they are subtracting. So straight away I can factorise that so that it becomes 4 times 2x plus 3 times 2x minus 3. And then I've got the x minus 7 on the denominator. I'm going to go ahead and flip this second fraction. Remember, when you're dividing fractions, you can change the sign to a multiplication sign and flip the second fraction. So the x minus 7 times the x plus 2 goes on top, and then the 2x plus 3 and the x plus 2 goes on the bottom. Now, straight away, actually, top and bottom, these two cancel each other out because they're dividing each other. If they're on the top and the bottom, they cancel each other out. Now, looking across, I can cancel out some more things. The x take away 7 cancels out the x take away 7 here. And then the 2x plus 3 cancels out the 2x plus 3 here. And so what you've actually got left on this side, and actually I realise I've forgotten the minus 7 plus 8x here. So what you're left with here is 4 times 2x minus 3. And that's it, because this whole fraction here has been cancelled out. Take away 7 plus 8x. So then let's multiply out the brackets. I get 8x minus 12. And that's take away 7 and take away 8x. So 8x take away 8x, cancel each other out. And then minus 12 take away 7 is minus 19. Okay, I think only one person may have got this one right, so it was quite a big one. Okay, on to another one that I didn't entirely like. So for this one, again, I don't know how many people, maybe no one got this one right. And this one was also quite hard. So, and we needed to use advanced trigonometry again. Partially. Oh, no, we can do it without advanced trig. So let's have a look. So here we know that this is x. We've got a right angle triangle here. We know that these two, because these two are the same, it means that this whole shape here, yeah, is a kite, which means that all we've done is split this angle in half, okay? And because it says that it's an equilateral triangle, we know that each of these angles must be 60. So here it must just be 30. And obviously we can do 90 plus 30, which is 120, and then subtract that from 180 to give this as 60. So that must be 60. Okay, so what I would do is, because we're trying to find the shaded area, in this case, what I would do is find the area of the whole triangle here. So we're going to find the area of the whole triangle here. And the way I'm going to do that, in fact, you could use half AB sine C? No, because you don't know AO. To be honest, we still have to find one of these sides. So I'm going to find the base and do half base times height anyway. So let's find the base. So this is the opposite. That's the adjacent. So we're going to use TOA. And when you cover up what we're trying to find an expression for, which is the opposite, it's telling me to multiply. So I need the base. So the base of this triangle equals x times tan 60. So we've got that. So we know it's x times tan 60. Then that's the whole triangle. I can subtract. Well, no, first of all, I've got to find the area of the triangle. So area equals half the base. So x times tan 60 times the height, which in this case is x. And so the area of the triangle, we'll just write it like this. X times x is x squared. We've got our tan 60 there. I'm not ready to simplify that yet. Over 2. So over 2. So that's fine. Then, to find the area of the shaded bit, we want to we need to take away the area of the sector. So it's this bit here that we're subtracting. We're taking away the area of this sector. And so that's going to leave us the shaded bit. All right, so what is the area of the sector? Let's work it out. So area of sector. The area of sector is 60 over 360 times pi x squared. So remember, pi x squared, because x is the radius, will give you the whole circle, but I don't want the whole circle. I only want part of it, which is the sector. So that's why I've got this 60 over 360, which simplifies to pi x squared over 6. So then we're almost there. To find the shaded part then, just leaving the shaded part, I'm going to have to subtract them. I'm going to have to take the whole triangle, which was x squared tan 60 over 2, and take away the pi x squared over 6. Okay, so I need to subtract those. I think I'm going to keep it like this for now. I'm not going to put it straight in my calculator just yet. In order to find out what tan 60 is, I'm going to make both denominators the same. So I'm going to multiply top and bottom here by 3 to make it over 6, so that I get 3x squared tan 60 over 6, take away pi x squared over 6. And so that now they are combined, I can take out the x squared, leaving 3 tan 60 minus pi all over, so I didn't need to put a bracket there, all over 6. And so I've got that all over 6. And so actually that, once I've got that, so I've subtracted, that gives me the area of the shaded bit. And so just to go back, so that gives me the area of this bit. Now I've got 6 of these. I've got 1, 2, 3, 4, 5, 6 of these. So I'm going to take that area and multiply it by 6. That's going to get rid of this bit here. And so here we've got the x squared. We just need to now work out what 3 tan, so x squared, so the area of all those shaded bits is x squared times 3 tan 60 minus pi. And when you work that on the calculator, that gives you 2.05 x squared. So n is 2.05. Okay, almost there. Almost there. Last one then. Okay, you do not have to draw a tree diagram here. It just might organise your thoughts. And so I did end up drawing one to kind of organise my thoughts. So we've got our friend picking 2 counters, and there are blue, orange and pink counters, bop. And she picks 2. So we actually can draw this another few branches, okay? You can, as I said, you can do this without drawing this. Now, 6 blue counters, and it tells you that there are 25 counters. So 6 blue, that one's nice and easy. 6 out of 25 is the probability. There are X orange, so X out of 25. And then the rest are pink. So I would need to do 6 plus X and then subtract that from 25 to find out how many are left. So if I tidy that up, 25 take away 6 is 19, so it's 19x over 25. So that's that one. I know that all of these are going to end up being out of 24 now, because she does not choose one counter, then put the other one back. She takes two counters straight at the same time. So now the probability of getting any of these has now become out of 24. This one is nice and easy. If I chose blue first, then of course there's only going to be 5 blue counters. To be honest, I'll just concentrate on the ones they want me to do. So they want me to calculate the probability. Actually, I will fill this all in really quickly. So this state remains as X because I only chose blue at first. And this stays as 19 take away X. Now, on the middle, if I chose orange first, this still stays as 6. This becomes X take away 1 over 24. And this one stays as 19 minus X over 24. Last one then, blue stays as 6 out of 24. Orange stays as X over 24. X over 24. And then because if I chose pink before, then it's got to be 1 less. So that becomes 18 take away X over 24. Okay. So the bit of information they do give us is that the probability that Malum takes 1 orange counter and 1 pink counter is this, 22 over 75. So where does that happen? So she takes 1 orange and 1 pink. So it could be those two. So let me write that down. X over 25 multiplied by 19 minus X over 24. And the other possibility is that it was pink first and then orange. So that is going to be 19 minus X over 25 multiplied by X over 24. So let's multiply those out. That gives me 19x minus x squared over 600. And then this one gives me 19x minus x squared also over 600. Then if I add those two together, so if I add those two together, I get 19 plus 19, which is 38x, and minus x plus another minus x, I get minus 2x squared, sorry, minus 2x squared, all over 600, and that gives me 22 over 75, as said here. Right, let's solve it. I'm going to multiply both sides by 600 to get rid of it here. I'm going to times that by 600. And I end up with 38x minus 2x squared equals 176. Then I'm going to divide it all by 2 just to make it a little bit less messy. So let's divide it all by 2. And I get 19x minus x squared equals 88. I will take everything onto this side. So it becomes x squared minus 19x plus 88 equals 0. and hopefully that's something I can factorise. If I can't factorise it, then don't worry, you can usually solve it then by using the quadratic formula. But let's see, two numbers that multiply to make 88, but add to make minus 19. We've got 11, so x minus 11 and x minus 8. Okay, so now I've solved it. X equals 11 or x equals 8. Now, going back to the question, it says where x is greater than 9. So that is your only solution. So that's the solution. Okay, it cannot be this one because it says where x is greater than 9. So x equals 11 is our answer. Now, let's go back to the question, which tells us to find the probability that Malum takes 2 pink counters. So 2 pink would be just here, so this one times this one, that's all I want. And so it would be, let's work it out here, so it'd be 19 take away x over 25 times by 18 take away x over 24. Now I know x is 11, so 19 take away 11 is 8 over 25, multiplied by 18 take away 11 is 7 over 24, which gives me 56 over 600, which simplifies to 7 over 75, and that's the final answer. And thankfully, the end of the paper.